Hello everyone, welcome to my channel. This video is a follow-up to a video that I created a little time ago, a short while ago, that talks about kind of optimizing experiences when people look through a telescope as part of public outreach. That's what I did in developing many different kinds of public outreach presentations, especially stargazing ones. But I think that these skills or these ideas can be employed or used as part of anyone's experience when looking through a telescope. If you are going to show people something through a telescope, many of these ideas might be something pretty powerful to take advantage of. And today what I'd like to discuss is what happens after you have everyone aligned. So if you haven't seen the previous video, please go check it out. It's how I explain how to get people to align their eye to be able to look through the eyepiece well and be able to see things. They've got to get their head and their eye all lined up. You might think, how hard could that be? Watch the previous video. It actually goes into some depth about it. But then you have this other problem, and that's what this video is about. The other problem is about once you have people aligned and they're seeing something in the telescope, they would like to have a focused image. They want to have as crisp and as sharp an image as possible to see whatever thing in the universe it might be that you're showing them. And that poses some interesting challenges. The main challenge here, I just want to give you the theme, is that if you have someone looking through a telescope and they make an adjustment, you're basically just guaranteeing that the next people that look through the telescope, they too are going to need to or want to make an adjustment. Now, if you only have 2 or 3 people looking through a telescope, this is no problem at all. But in my case, what often was happening is that I had 20 or 30 people that needed to look through a telescope, and not at just one object, but many objects. And the overhead in time to be able to have people individually, for their own eyes, focus the telescope is very large. I mean, it's just not possible. So instead, you need to devise some strategies that optimize or make more efficient that process. There is something of a compromise here, though. Consider the fact that if you go to some public outreach programs, say at large observatories where they might have some event and they want to show things through the telescope, generally no one gets to adjust the focus. It's just fixed. It's just set by the operator or the presenter, and everyone just peeks through the telescope. Of course, when you have a large group of people, that may be the best that you can do. But as part of programs that I was able to present, I try to find a compromise, something that is a little bit better than that. And here is the idea. The first idea is that I would always take advantage of being able to show things in the daytime sky because it makes life much easier. People can align their eyes to the eyepiece with more ease, and they can see things that you want to show them with more ease. Though the technique that I'm about to demonstrate works just as well as at nighttime. But daytime I think is the right way. One of the cool things that I took advantage of is to be able to show daytime stars, stars in the daytime sky, if you will. And seeing stars against the daytime sky makes it, first of all, it's easy to find. All they see is blue, and then they see the one star, whatever it is that you want them to see. And then in and out of focus, the nature of what in and out of focus you can demonstrate with a little more ease against the daytime sky just makes for a very comfortable viewing and appreciation of the subtlety of being in and out of focus. Now, I'm going to go into the detail about this, but I just want to express kind of an anecdotal thing. How important is this idea of telling people the nature of how, to be in focus is not only important, but if you don't explain to people what out of focus or in focus images looks like, you can actually damage your telescope if you don't say the right thing. You can actually stop a public program, in my particular case, because not explaining it can lead to some interesting problems. When I began doing public outreach presentations at the National Observatory at Kitt Peak, the telescope that I first began these programs with was a 16-inch LX200. And at the back of the telescope, to focus it, there's a knob. And that knob, if you actually take it apart, the way it works is when you twist the knob, it moves by virtue of this kind of steel bolt. It moves the primary mirror in and out. At the end of the steel bolt, there's a little hole, and it slips over a little pin that connects to the primary mirror, and the mirror slides up and down on the central baffle. That's what focuses the telescope. But the nature of this focus knob is such that it has this inner steel bolt, very hard metal, and then there is an outer brass kind of coupled ring, cylindrical bit that is threaded on the inside. And it's the bolt as you turn it through these threads that causes the mechanism to move the primary mirror in and out. And that brass coupling is much softer than steel. I think you can see where I'm about to go. At the end of it, there is actually a hard stop. Here's what happens. When people look through the telescope, or this is what happened, some people looked through the telescope and they didn't see anything. The problem was that they were not aligned with the eyepiece. That was the problem. And so they weren't seeing anything, they just saw blackness. So what they would do is turn the focus knob. And in this kind of deadly feedback loop, they would keep turning the knob, not see a change because all they were seeing is blackness, and keep turning the knob thinking that they're not seeing anything because the telescope is out of focus. And of course, that's not the problem. The problem is that they're just not aligned. There were some people that continue to turn the knob. It only takes 15, 20 seconds of turning the knob until you reach that hard stop. But brass, it's kind of soft. You can continue to turn it, and what happens is the steel bolt goes right through that brass coupling, taking all the threads out, and now your public program is done. There's nothing more you can do. You can no longer focus the telescope, and you actually need to wait to get a new focus knob to begin doing other public programming. When you have many nights lined up consecutively, that's a problem. So the lesson that I learned so many lessons here. The lesson I learned, of course, is one about having backup pieces like focus knobs. Now, how do you know you need a focus knob as a backup? You learn very quickly in this particular case. I think I probably learned the first time, but it might have taken me 2 times to really make sure that I had these backup focus knobs for this telescope, just in case this happened. The fix was really only 5 minutes to pull one out and then put another one in place to get everything back up and running. It's not really a big deal. But here's the fundamental problem, and I would actually ask you to pause the video. What was the problem? What is it that I needed to tell people so that they would not do that? So hopefully you thought about it for a moment. Of course, here's the answer, and it's the most fundamental aspect of the focus problem. You need to always tell people that in focus or not, they will always see light coming out of and through the eyepiece. If they don't see anything in the eyepiece, it does not mean, of course, the telescope is out of focus. It is an alignment problem. You only turn a focus knob once you are actually seeing something in the telescope. And that is the most important key. That would have saved me, had I known it was going to be an issue, saved me from some disasters when it came to focusing the telescope. Now, let's say that there are no disasters here. Now we just need to optimize, this idea of having people look through the telescope to be able to see things well. Well, one of the things that I can do, and it doesn't need to be in the day, but it was much easier and much quicker for me to do this in the day, is to show these daytime stars. And I would let everyone look at a star that I focused on and no one touches it at all. And what I ask people to do is see what they see. I describe what an in-focus image of a star looks like. An in-focus image of a star is a small, sparkly ball of light. With the telescopes that I was using at the time, if the stars instead took the form of donuts, those are bright rings of light with little black centers in them, then, unless they're Homer Simpson or, eating Cheerios, they do not want to see donuts or Cheerios through the telescope. That's bad. Those are out-of-focus images. And those people I would name as fiddlers, because they're going to want to fiddle with the telescope, make an adjustment so that they can focus for their eyes. But they wouldn't know that in advance. Everyone is potentially a fiddler of the telescope in the very beginning. Then when everyone cycles through, we learn some people are going to have vision that's very close to mine. My vision at the time, anyway, when I was doing this, as far as public programs, I could focus, and I think my vision was quite average, so that a certain healthy fraction of the group found that they were seeing a small, sparkly ball of light. They were unable to see a black center or some kind of less light or depression in there, nothing that would lead them to believe it was out of focus. So that's a happy group. Now, what you're going to also find is that when you have everyone look, you'll have everyone go back and make an adjustment if they feel they need to. So now we have two other kinds of people. We have the people who literally did see out of focus images because they removed their glasses, or perhaps their vision was just significantly different than mine. That's fine. They are going to want to adjust the focus of the telescope. But then you also have another group, and this is actually a very important group. You have the fiddle curious group. These are people who want to make the adjustment at least once, certainly, if not other times, and they want to see how good they can get it focused compared to what I did. And the nice thing is that if they find in making these adjustments that my focus is actually quite good, they can't seem to get it any better than what I'm doing, they're going to be converted to a non-fiddler, and they're just going to enjoy the views through the telescope for the rest of the night. And then we're just left with the true fiddlers, and I ask them, the people that need to make adjustments, to be at the end of the line. That's the key. Everyone who wants to make an adjustment can. We'll make sure that everyone gets to see whatever it is that we're looking at. We won't go to the next object until everyone has had a chance. But those people who want to make an adjustment, just make sure that everyone who did not make an adjustment has already looked. And I just want to stress this point. It isn't just, because this is the way it works with kind of human nature, it isn't just that people are getting an opportunity. There's the other side of things, which is if someone in the beginning or near the beginning makes an adjustment, and I've seen this happen so many times in public outreach programs, someone makes a little adjustment. They don't tell anyone. They weren't told not to. They just make a little adjustment because they know where the focus knob is. Now, the next person that goes to look, it's out of focus. But this person either doesn't know it's out of focus, and so they're not getting a great view, or, more generally, what happens is they're not going to really feel the need. They might be shy. They're not going to want to speak up and say anything about that. So they look, and then the next person looks. Now, if you're the presenter, after 20 people have looked through the telescope, and you go look again, and now you see it's out of focus, I hope that would give you some pause for concern for the quality of the presentation that you're giving. I wouldn't accept that. That would be unacceptable to me, to know that 20 people that just look through the eyepiece, and when I look it's out of focus, and no one was an adjuster or a fiddler of the telescope. So I worked very hard to kind of engender that kind of feeling in the group, that people would actually ask, have you already looked? I'm going to adjust the focus of the telescope. And so that became a thing, and it, I think, made it a much more successful experience for people because it was a way in which people could guarantee that it was either going to be what I did, my average focus, or they were given a chance to make an adjustment knowing that, if someone ahead of them has made an adjustment, it could be anywhere in there, and they're just going to have to make it to optimize it for their own eyes. So that's the key. It's something that I have not seen in any public outreach programs that I am aware of. Perhaps in the comments down below, let me know if you think that there is yet a better way of doing it. This is a method that you can identify who the people are that are going to make an adjustment. I'm not saying you're quarantining them, but you are certainly creating a separate group of them who are going to interact with the telescope differently than another group. And as long as you know who they are, or they know who they are, more importantly, you'll find that public outreach presentations, stargazing programs where you can't see what they're doing at the telescope because it's dark, but they will know what to do. And I think everyone has a much happier and more rewarding time in seeing these things through telescopes, things that are challenging to see in general. They can at least not have to worry about the fact that they think the reason they're not seeing it is because it's out of focus. No, that's not it. We've already demonstrated on all these other things that it is an okay view. And let me just leave you with a last thought. It's just important to mention these things. One of the things that sometimes a misconception, it's rare, but some people have this misconception that different objects in the telescope require a different focus because maybe they're at different distances. Of course, when it comes to astronomy, there is one focus that's going to focus things for our eyes, for everything that we look at through the telescope. So that was supposed to go without saying, but I should say it. And you should make that clear to anyone that's looking through the telescope if there is any question about that. So again, comment down below. Let me know what you thought of these ideas, and if you have a better method for your public outreach or maybe your sidewalk astronomy, I'd enjoy hearing about some of the ways in which you have found ways to optimize and make less frustrating this kind of experience. Thank you again for joining me. In the next video, I'm going to talk about other ways of success that include what are the first things you should show through a telescope, and other ideas that deal with the way in which people perceive what they're seeing through a telescope, both in terms of what their expectations are and in terms of how our physiology drives some of these expectations, all kinds of stuff. It is all steeped in the human nature of the way in which we interact with telescopes and peer into the universe. Thanks a lot. See you next time.